So I'm going to go through this agenda. First, just introduce quickly the Essential Eight for those that haven't heard of it. Hopefully, I'm assuming that hopefully all of you have. Certainly the people from ASD in the room will be hoping you've heard of it. Then talk about just to remind you about our approach to security. And if you've had an introductory session on AWS security, you would have seen something like this before. Remind you about the shared responsibility model. So again, in your organisation, I'm sure you've talked to people and told them security is everyone's responsibility, and that's no different in the cloud. But then I want to spend most of the time walking through the Essential Eight and giving you some pointers on some of the services and features you can use to meet those objectives. So the ASD Essential Eight, what are they? So it really comes from ASD have published a cyber security mitigation strategies. So over 30 now. I think maybe over 36. It keeps changing from time to time. Now, within these strategies, they've been prioritised. There's well documented on their site. There's no one strategy in those that guarantees that you'll be safe from cyber security incidents. Just like any security posture, you're looking at a layered approach here. But there are 8 mitigation strategies that have been identified as being regarded as essential. That they recommend as the baseline that all organisations should put in place. And in fact, these it was previously the top 4, now the Essential 8. These are important enough that organisations like the ANAO look at organisations to make sure these are being put in place. And I've got a link to these if you haven't seen it before. So what are they? What are these Essential 8? So I've put them in the categories here. Again, this is from the categories that are being used on ASD's website. So the first 4 here are controls that you should put in place again around trying to prevent malware actually running on your environment. So patching, application whitelisting, which should be familiar from the top 4, and then they've added use application hardening recommendations to that. And then the second half here, the other 4, are around limiting, if there is some sort of unauthorised application running, limiting the effect that could have. And so things, again, that can help here is patching, of course, but then reducing admin privileges, which if you were in here the last 2 sessions, you would have heard that mentioned multiple times. So this is not a best practice just for ASD, this is a best practice in the industry. And then things like multi-factor authentication and backups, particularly in those sort of ransomware scenarios. If you've got a good backup strategy, you're usually in pretty good state. So what is our way of thinking about security at AWS? So for us, security is really job zero. AWS as a business, we really don't have a business if our customers aren't comfortable with our security and how we operate and how they can operate in our environment in a secure and safe fashion. Now, we have millions of customers across the globe, thousands of government customers, as you would have heard about some of those in the keynote today. Many of those customers have very stringent security and compliance requirements that they lobby on us and expect us to implement on their behalf. The great thing about the AWS architecture and how we have uniform architecture deployed in separate regions across the globe is you get the benefit of the aggregation of all those controls. So you get the union of all those controls that we've implemented for US agencies, federal agencies across the globe, financial organisations and so on. Our security model is a fairly familiar one that you should be pretty used to here. So I've talked to the layers here on this diagram. So it starts at that physical layer. So it's the usual things, securing the data centres, guards on gates, fences around data centres, only getting access if you have a legitimate need to, and so on. Then moves up to the network layer. So securing our perimeter, and we've touched on some of that with some of the DDoS presentations today. In fact, so making sure that connectivity in and the transport within our environments is a secure manner. And then building our services in a secure fashion and operating them securely at that systems level. And then finally, the people and processes, just like you have in your own environments. ensuring that only those that need access have the appropriate level of access, and when they no longer need it, revoking that access. Now, I've said we do all these things, though, but how do you know that we actually do them? And how can you be assured when you're building a system on us? And that's where our compliance program is really important. And so we've invested heavily in this space. So across the globe, many internationally recognised compliance regimes like ISO, SOC, PCI that you may be familiar with, we've undertaken those audits. And you can get access to those compliance reports very, very straightforwardly. Then we specialised into the government-specific space here, so things like FedRAMP in the US. And then most relevant to this audience is the IRAP certification process that we've been through, being audited against the ASD ISM controls. And as a result of that, we're now listed on the ASD Certified Cloud list, which I've listed up here. So we take that responsibility of securing security of the cloud very seriously. Now, security, though, is a shared responsibility. And so if you've worked in, say, defence environments, you might have even seen posters on the wall where they say, security starts with you, or security is everyone's responsibility. And it's no different in the cloud. So we give you a lot of flexibility here and control and services that you can leverage to build your security posture. So we're responsible for the security of the cloud, but then when you run a system in the cloud, you need to decide how you're going to secure that and to what level. So a good example of that is if you, say, spin up a virtual machine, you're the full administrator on that. We don't have any access to that virtual machine. You then decide, do I patch it, when I patch it, do I encrypt data on it? What data do I put on that? What identity and access management system do I use? Say, my own AD, another AD, etc. Now, if you've been to some of the sessions earlier today too, we don't leave you on your own in this space. So we give you a lot of best practices and guidance here. And we went through a great set. Phil went through a great session today, walking through some of those. So I'd encourage you to. This talk doesn't replace those. It's really just to give some local context around security. So let's dive into the Essential Eight and let's walk through each of those. So the first one is patching. So patching both OS and of applications. Now, all of these, I'm going to sort of try and divide into these three sort of areas of approaches. So the first one is AWS runs a Windows or Linux environment. You can run up multiple versions, different versions of Linux, different versions of Windows. It's an x86 style environment. So if you're already running patching and automation tools in your own on-premises world on those types of environments, it's highly likely you'll be able to continue to run those within an AWS EC2 environment, which means you can leverage your existing skill sets and existing teams to continue doing patching just as you're doing now. And so that's that first column there, that existing tools. Now, of course, we also recognise that customers may be looking to us to help them in this space around patching, or there may be issues with some of their existing tool sets when they move to the cloud. So occasionally there might be licensing issues where traditional tools aren't used to a world where you can have thousands of servers coming on and offline rapidly in auto-scaling modes, those types of things. So we've introduced some tool sets here, which I'll talk to next, to help you in this space. Or you might use some of our sort of services like developer-based tools like Beanstalk that has patching as part of the service available to you. Or use one of our database as a service offerings, things like relational database service or Redshift that actually include patching as part of the service for you. And then the third column here is when you move to the cloud, you've got the opportunity to potentially look at things a little bit differently. This is what I've called sort of cloud-native approaches. And this is where you might have heard of people talk about things like infrastructure as code, immutable infrastructure. So you can actually start to look at patching in a little bit different way. Rather than patching existing fleets of servers, I just stamp out a new copy of my whole infrastructure. Or you might even move further to that serverless approach where people have mentioned things like Lambda, and I'll touch on that shortly. So at the end of last year, around November, at our reInvent conference in the US, we introduced some new capability to Amazon EC2 called Systems Manager. And so this was a collection of capabilities that allows you to perform automation tasks, management tasks, including patch management. You can use this to patch EC2 instances on AWS or your own on-premises instances, or that could be potentially other cloud instances, for example. And we offer this at no cost, so there's no additional cost for using this service. It has a collection of features here. This could be a whole hour talk on its own, so I'm not going to touch on all these, but things around deploying, configuring servers, setting up maintenance windows, setting up areas to store credentials and secure data, and then things like tracking, inventory control, understanding what your environment looks like. We're just going to touch on the patch manager aspect here. So what does patch manager do? So pretty simple, allows you to set up patch baselines, so you define what patches I want to apply. So do I want to do all patches that come out from the vendor, or just critical patches, or just security patches and so on. You want to set up a maintenance window, when am I going to patch? So you probably don't want to patch during day, business hours, you might want to patch after hours. And then I want to report on those. Has the patching actually been done, and can I show someone a dashboard to prove that? This is just showing quickly, I don't have time for a demo, but this is my own environment here from my own console. So this is crawl mode, as Phil used in his conversation. We're doing it in the console here. I've set up some baselines for both Windows and Linux. Here I'm just selecting critical patches and waiting 7 days before I apply them to give, say, testing time to occur. And then I've got a dashboard here. I can quickly see, yep, my instances have all been patched and are in a compliant state. So that's the sort of middle column there. So let's just move to that cloud native column. So if you're in an environment like AWS, you've got the opportunity to start thinking of infrastructure like code. So this is where people start doing things like stamping out standard images of servers. So we have a golden image of a server. I know I can run that up at any time. I can auto scale it. I can dispose of it. I can run up a replacement when needed. I then tie that together, say, with a script, so things like CloudFormation, or some people might use Terraform or other products to script an exact configuration of your environment. What that means then is you can then update that infrastructure as code to a new version, and going to that new version includes, say, all the new patches. To roll that out, then you can simply just run up a new copy of that infrastructure, make sure it's working, and then just dispose of that old infrastructure. So it's achieving the same outcome, but in a different way of thinking. Or you might go to that full serverless world, where you can use a service like AWS Lambda, which allows you to just focus on the actual bit of function or the actual code that you want to run, and to have that deployed to a service, and we run that on your behalf. And so we're handling all the details under the covers around scaling, reliability, and of course, patching. So let's move on to, so we've covered patching, OS and applications. Let's look at application whitelisting. So again, these sort of 3 columns of thinking I think you can apply to this issue here. So on the existing tool side, if you've got existing products in the Linux or Windows space that help you and you're comfortable using, by all means continue to use those here. So in the Windows space, within Windows you've got a product called Windows App Launcher. So again, you can configure that to run on EC2 and leverage that capability. You might be using group policy objects to control what can be installed and installing applications. Again, you can continue to use that here. We actually have a quick start around using PowerShell or desired state configuration on the AWS platform. So again, you can, if you're comfortable using these things, you can continue to use those. And then, of course, you can start to use some of our services to augment or automate and make some of the application of this a bit more straightforward for you. So if you want to use Active Directory, we've got a service to run that in a managed fashion with Directory Service. These systems manager capabilities for automation can be used to help you, say, deploy some of those things like App Launcher. And then there's a whole capability within Systems Manager around that inventory control and understanding what your environment situation is looking like. So if something does get added to your image, you can very quickly understand what has been added. And I've listed security groups down here, and so you might be wondering why that is. So that's just the firewall, like we talked in an earlier session, that firewall around your instance. Well, if you know exactly what applications are running on that instance and what ports they need, you should be locking that security group down to only those ports. So that does at least prevent one attack vector, as if another application is installed that needs other ports, it's automatically blocked. And then there's cloud-native approaches. How does that change this world here? Well, if you're baking your infrastructure as code in a controlled fashion, where you update it in a controlled way through a development pipeline, that's starting to put those controls around what's installed on that infrastructure. So potentially you can remove the need to even log in interactively and install things in an ad hoc manner. Again, if you move to that Lambda model, where you're just focusing on your business code, again, there's no opportunity to install additional software there. For end user type tasks, so if you're looking at, say, providing an end user with a specific application, you might want to look at things like Amazon AppStream, which is an application streaming as a service offering. So you can just stream a specific application to that user that they need, and they have no access to the underlying OS. So one of the features in Systems Manager, called State Manager, this basically gives you the ability to set up templates to say what the configuration of your server fleet should look like, what the configuration of the OS applications on that server is. And this can help you then enforce and automate the keeping that server in that desired state. The inventory component of Systems Manager allows you to see exactly what's installed on those server fleets. So what patch level you're at, what applications have been installed, and so on. This actually integrates with the AWS Config service, which we've mentioned in a few talks here. And I've got a diagram to show how this works now. Config, when it originally came out, gave you configuration of your infrastructure sort of from the outside of the EC2 instance view. So it showed you what the security groups were, what the VPC configuration was, what your EC2 server was configured as, but it couldn't see inside that server to say what OS patch level and so on was. With SSM now, you've got the ability then to feed that data through a Systems Manager agent, through the inventory store, which then integrates with config. And what this means to me sort of in practice is this is my config console here. I've got a server running here, and I can actually go back and see a complete timeline view of what changes have occurred on that server, including right down to when I've installed a Windows update, when I've installed an additional application on that server. And so in addition to actually seeing that it's there, Config Rules then takes you that next step further, where you can actually say, if something changes and it's out of compliance, actually do something about it. So you can there's already built-in blacklist, whitelist rules here. So you can say, if this software is installed, trigger an alarm, or you could then build a Lambda function to say, take some automated action here. So let's keep moving on. We've got to get through 8 here. So restricting administrative privileges and multi-factor authentication. So I'm starting to cheat and put two together here. So again, existing tools, existing ways of doing business you can apply here. So existing Windows and Linux best practices around limiting privilege access should be applied. If you're using Active Directory, you can integrate that with multi-factor authentication. So by all means, use your best practices at the OS level that you know and maybe love. And then on the AWS side, you need to think about limiting access to the AWS API layer. So we support a very rich identity and access management service. So in the last session, you saw some of the depth that you can go there. You can go to a very granular control what people can do there. You can use organisations to control a group of accounts. So again, limiting who can do what and limiting them to single accounts. Some of our services, things like workspaces, directory service, again, support multi-factor authentication. There's also then the opportunity to not only implement these, but then continually validate it so you know you're in a compliant state. So I've listed a few services there that you can touch on to look at those. And then again, I encourage you to think about that third tier here, those cloud-native approaches. So how does that change the situation here? Well, again, if you're moving to that infrastructure as a code approach, where you're stamping out a complete infrastructure as essentially as a software update. Potentially that means you don't need to let people log into those servers at all. You just stamp them out in their configuration, they automatically start up in the state they need to be. And so again, that completely limits the sort of admin access issue there. Or you might use the run command, which is part of Systems Manager. That allows you to send a command to a fleet of instances, but in a very controlled manner. So you can set up documents to do specific tasks, and actually each one of those documents can be specifically locked down with IAM. So maybe Joe's the only one that's allowed to do these particular admin tasks, whereas Bob can do a greater range of tasks. And then, of course, serverless approaches can take you that step further. You're just focusing on code. That code runs in an IAM context in a very locked-down fashion. Service catalog, if you do have this infrastructure as a code approach, you can potentially start where you can use a service catalog where you say, these are my offerings. So again, people don't have to interact at an admin level. They can just request a standard offering that might be my web stack on AWS. Just wanted to show restricting access based on usage here. So this is where you can start automating things. So I can actually go, I've got a user called Bob in my account. I've given him some privileges. I can actually see what privileges he's used in the past. So I can see he's used the first 3 there, but he hasn't used the last 2 for quite some time. So maybe that might prompt me to manually revoke those privileges, or take it the step further, the walk and run, automatically revoke those. Tools like Inspector, it can actually scan your environment. Here it's telling me one of my servers needs to be updated with some new pseudo software. So backup of data. So again, these same sort of 3 columns I think apply here. So Windows, Linux backup tools that you're using now, you can continue to use those within your environment. On EC2, you're typically going to be using what's one of our services called EBS for disk storage. EBS includes, as part of that service, the ability to do a snapshot. So you might leverage that as part of your backup regime within the environment. In fact, many third-party software tools in the backup space actually directly support some of our storage services like S3 and Glacier. So if you're talking to them, any of those partners, your existing backup partners, you might want to ask them whether that's already supported. I've got customers that already just go into, say, their backup console, select S3 as a backup target, and then they know that their backup's being sent to a secure, reliable location. Or you might want to start thinking also about leveraging some of our services that can help you in this space. So things like our relational database service. So as well as doing patching as part of that service, it does automated backups as part of the service for you, and can keep those for up to 35 days. You can then put in manual backups to keep for however long you need to. Similarly with Redshift, which is our data warehouse as a service, again, it does automatic backups to S3 for you, and then you can take manual backups as and when you need to. And then finally, this third column here. So cloud-native approaches, how do they change how you think about backup? So if you're talking about that infrastructure, the code, immutable infrastructure approach, you're moving to a world where you've got every service defined by a standard, say, golden template that you've got securely stored somewhere. So, and you know at any time you can stand up that server exactly as it should be from that template and maybe a config file. You combine that with, say, things like your CloudFormation templates to describe what the infrastructure connectivity looks like. You can, at any time, create a copy of that infrastructure. So do you need to actually do image-based backups of every server in the fleet because you've removed that vector where someone can randomly come in and say one server's not quite the same config as the other server? So a little bit different there. I mean, you certainly need to start thinking about, well, how do I then back up customer data side of this separately, but maybe you can reduce your overall backup volumes. Things like S3, if you are using S3 as your backup target, and that's a very common use case there, you then want to think about, well, how do I make sure that's a very protected from accidental deletion, those types of issues. Because we keep 3 copies for you, but you could, of course, could accidentally go and say delete that, and that might be your big backup file. So we give you features again to help you in this space. You can turn on versioning, and if you do that, even when you say delete, we're just putting a delete marker there for you. You can go back and see the full history of those objects and manage that for you. You can turn on things like multi-factor required for delete. So you can say and essentially lock that in a safe, and it becomes then the only way something's going to get deleted then is if someone breaks glass and goes into the safe type thing. So application hardening and the sort of untrusted macros lockdown. So the existing tools here, this really gets back to that shared responsibility model. You have full control of your EC2 instance. If you're running desktop as a service with something like Workspaces, again, you've got full control on that desktop image and its configuration. So you've got the control to disable untrusted macros, lock down your applications as you need to. So you can continue to use those same existing tools and processes. You can then, of course, leverage things like Systems Manager. So this has an automation component. We haven't really had time to touch on that here. You can use that as part of the process to configure those server images and lock down your applications as you need to. And you can add on those network controls. So again, like I said, if you know what your application footprint looks like, what its ports requirements are, you should be locking down those security groups to only those ports and sources and destinations. And then finally, of course, that third column, I encourage you to think about that. Can I use more sort of cloud-native ways of thinking in this space? And so one thing here that I've seen some customers do is, for example, is set up, use Workspaces as like a separate, isolated desktop environment. So it starts changing the sort of the threat profile of it's not their corporate desktop, but they can get internet access, or it can be a desktop that doesn't have any internet access. So you can set up very distinct desktop environments with different security profiles. Or you can take that even further and say, well, I'm actually just going to give the end user a streamed application, and that's where something like Amazon AppStream can be used. So you just give them the actual application they actually need, and takes away that whole interactive OS management sort of option. So to sum up here, I've given you a bit of a picture of an introduction of what the ASD Essential 8 is. Hopefully you already knew, everyone here already knew what they were and had heard of them. If you hadn't, I can point you to some people in the audience to give you a briefing on them. I talked about how we approach security, and importantly, just a reminder about the shared responsibility model. So security, as you know, is everyone's responsibility to make sure that we keep our citizens in a safe state. And then walk through those Essential 8 and how you can meet those requirements in the AWS environment. And I encourage you to think about those sort of 3 pillars that I went through there. So you can, in many cases here, you'll be able to use, if you've got existing tools and processes that you've found are efficient in meeting those, by all means, it's highly likely you'll be able to continue to do that in AWS. If you are looking for tools to help you in those things like patching, automation, we have offerings that can help you there. Like I said, Systems Manager, no additional cost for using that. So it's pretty easy to experiment and try out. And then if you are moving to those sort of more cloud-native models, if you're starting to think about moving to serverless models, infrastructure as code, have a think about how that changes, how you achieve the outcomes, the desired outcomes of the Essential 8, but maybe not in as traditional ways as you might have first thought. So thank you all for your time, and I'll be around later for questions.